Now don't forget, because it is a state function, we can also sort of use what we have introduced as Hess law in the previous chapter to be able to calculate the change of entropy of a reaction based on sum of different reactions. You can refer back to the Hess law in the previous segment to be able to use this again for delta S, which is also a state function. Finally, the spontaneous process at low T is also commonly referred to process that is enthalpy driven, while the process that is spontaneous at higher temperature is called the process that is entropy driven. And this is due to the contribution of either enthalpy or entropy to make the delta G becoming negative. In the process at low temperature, the enthalpy drives the delta G to become negative, and at high temperature, the entropy instead that drives the delta G to become negative. So delta S and delta H can be used to measure delta G, so you use this formula again. And the second way is that also based on reaction, just like the delta H, we also have the delta G formation. And just like delta H, for any elements at their standard state or their most stable state, the delta GF is also 0. So say we have a reaction again of 2A plus B forming to C plus D. We can calculate the delta G of the reaction from the sum of the coefficient multiplied by the delta GF of the product minus the delta GF of the reactants. Don't forget to also use the stoichiometric ratio. So let's take a look for this reaction. Then how do we calculate the delta G? Delta G is equal to 2 multiplied by delta GF of C plus 1, because the coefficient is 1 here, multiplied by the delta GF of D minus the reactants. Don't forget the coefficient. So 2 multiplied by delta GF of A plus 1, because this is also 1, multiplied by delta GF of B. Just like the enthalpy, where we can find the delta H of a reaction based on the delta HF also of the products minus delta HF of the reactant. In the process that involve phase changes, for instance, the phenomena of melting, the process itself is in equilibrium, so the delta G should be equal to 0. And in this case, you can see that if we write down delta G become delta H minus T delta S, since the delta G is 0, we can rewrite this equation to become delta H is equal to the T, in this case the melting temperature, multiplied by delta S. And from here we can calculate the melting temperature, or Tm, that will be equal to the delta H of the system or of the melting process divided by the delta S of the melting process. Don't forget the unit should be in Kelvin.